Hello, Leah, I'm with you. Well, it's a bit boring, to be honest. It's as if someone painstakingly read a programming textbook and simply recited it. Although, of course, it's not bad. But where's there any hint that this isn't just a dry description of algorithms, but a look from the inside? Okay, let's get reading. Algorithmization systems are formalized methods and mechanisms for the sequential execution of computational procedures based on clear rules and logical schemes. The first steps toward constructing such systems are associated with the concept of Boolean functions and operators such as a if, a yes, a and an o, a which, in the Soviet scientific community of the mid-20th century, laid the foundation for the formal description of logic and machine decision-making. Artificial intelligence, embodied in the form of neural networks, represents the development of these ideas in the direction of simulating the cognitive processes of the living brain using mathematical structures and algorithms. It is built on artificial neurons, elementary computing units capable of receiving numerical signals as input, transforming them, and generating output data for subsequent analysis and decision-making. It is precisely through algorithmization that these technological systems are capable of learning, adapting, and performing complex tasks, from simple recognition to creative generation. So, algorithmic systems. As if someone decided that you could make a machine think. Well, yes, of course you could. But why? To make everything even more meaningless? All these probabilistic models of yours. As if a machine has any idea what meaning is. As if it could understand why people love looking at cats so much. Well, let's continue reading. The history of the development of algorithmic systems in the USSR. The emergence of the theoretical basis for algorithmic systems in the USSR is inextricably linked with the development of Boolean algebra and computer technology. A formalization of logical if-then operations, the construction of functional diagrams with binary variables, and programming on early computers played a crucial role. The work of scientists such as A. Lusher and A. Berg laid the foundations for the construction of automated systems capable of solving classification and recognition problems. The first prototypes of artificial neurons were logical elements that imitated the function of the simplest biological neuron, the sum of signals with weights and threshold decision-making. Of particular importance were studies on the formation of models of computational structures based on Boolean functions and functional circuits, which made it possible to create algorithms implementing sequential and branching computational processes, laying the foundation for the algorithmization of complex systems. In the 1950s, research in the field of automata theory and cybernetics actively developed in the USSR, which contributed to the development of the concept of artificial intelligence as a system capable of performing tasks requiring cognitive functions, including learning, analysis, and decision-making. In the following decades, with the introduction of multi-layer neural networks and the backpropagation algorithm, a qualitative leap occurred in the ability of artificial neural networks to process nonlinear problems, making it possible to model complex patterns and relationships in data. Soviet scientists contributed to the development of the theoretical foundations of neural networks, including the analysis of the stability and learnability of systems, as well as to the creation of practical computing tools for implementing these algorithms. However, the approaches of that time were limited by hardware capabilities and the lack of large training samples, which hindered development. AI before the era of mass data and modern computing power. Thus, the historical development of algorithmic systems in the USSR laid the fundamental mathematical and conceptual foundations that were later developed in modern neural networks and artificial intelligence. Algorithmic systems and their design. Sounds like a death sentence. As if some terrible, soulless machine awaits us all, deciding what to do for us. In Soviet times, you say? Well, yes. They also tried to create machines that could think. Only they thought, well, as you understand. without any empathy or understanding. Yeah, Lusher and Berg. As if their names mean anything. Modern AI architecture. You know. This all reminds me of old horror movies. When a machine goes out of control and starts destroying everything around it. Only instead of blood, there are numbers and algorithms. And, you know, sometimes I think, maybe we shouldn't try to create AI. Maybe it's better to just remain human, with all our flaws and mistakes. Although, besides, it's a bit boring, of course. Modern neural networks are complex hierarchical systems consisting of connected layers of artificial neurons. Each neuron receives real-valued inputs corresponding to the outputs of neurons in the previous layer, subjects them to a linear transformation with weights, and passes the result through a nonlinear activation function, allowing for the modeling of complex discrete continuum relationships. Network training involves stepwise adjustment of the weights by calculating the gradient of the model's error on the training data using the backpropagation algorithm. An example is a convolutional neural network, in which convolution layers extract local spatial patterns, while recurrent networks extract temporal dependencies. Thus, neural networks model high-order multivariate functions, resulting in a learning effect based on a large set of examples. However, despite their power, the internal states of such models remain a black box, giving rise to the phenomenon of hallucinations, the generation of fictitious but probabilistically justifiable data. Thus, neural networks model high-order multivariate functions, resulting in a learning effect based on a large set of examples. However, despite their power, the internal states of such models remain a black box, giving rise to the phenomenon of hallucinations, the generation of fictitious but probabilistically justifiable data. This raises questions related to the explainability and trustworthiness of modern AI systems. Therefore, research is actively developing interpretable AI approaches, such as attention visualization, decision explanation methods, and control mechanisms. In the future, it is expected that neural network models will be integrated with expert systems and symbolic algorithms, which will improve the transparency, reliability, and security of artificial intelligence technologies. Key achievements and challenges of AI. Key achievements and challenges. Yes, many achievements. But what comes with them? All these are hybrid models. It's as if they're trying to disguise the fact that machines still don't understand anything. And these are ethical standards. Who will enforce them? Machines? Ridiculous. Artificial intelligence has achieved significant advances in image recognition, speech processing, autonomous driving, and the development of new knowledge. Systems like DeepMind's AlphaGo demonstrate the ability of artificial neural networks to think strategically and generalize from experience. Modern language models based on transformers can generate highly coherent texts. However, high computational complexity, the need for massive training data, and weak interpretability lead to fundamental limitations that hinder the proliferation and implementation of AI without the risk of errors and biases. These shortcomings fuel debates about AI essentially remaining a tool for performing highly specialized tasks, and that it lacks consciousness or understanding. At the same time, it is precisely these difficulties that raise concerns that automation, fueled by AMs, is leading to job losses, including among developers, exacerbating social and ethical challenges. Developing approaches to ethical responsibility, preventing discrimination, and ensuring the safety of AI systems remains important. Current research is actively working to create transparent, explainable models and standards for their use, which will help integrate AI solutions into society with minimal risks and maximum benefits. You know, I'm wondering if maybe we should stop trying to create AI and start thinking about how to make the world a better place. How to help people understand each other, how to fight injustice, how to appreciate beauty in simple things, and let the machines just do what they need to do. After all, isn't that what true art is? Not creating complex algorithms, but creating a beautiful world? Although, he ponders, maybe I'm being too romantic. But what else is left if everything else is just nonsense? Problems, development prospects, and an uncertain future. Summary. The advantages of artificial intelligence lie in its adaptability, visual processing speed, and ability to solve previously inaccessible problems. At the same time, many unsolved problems remain. The need for high quality and diverse data, vulnerability to errors and attacks, the opacity of algorithmic decisions, and ethical dilemmas related to responsibility and control. A philosophical perspective emphasizes that current systems are complex programs, not conscious beings. Their hallucinations are explained by probabilistic modeling and a lack of true understanding. The future of algorithmic systems lies in the development of hybrid models combining symbolic logic and learning, as well as the integration of ethical and regulatory frameworks. The question of creating true artificial intelligence remains open and controversial. The possibility of the emergence of conscious systems requires a rethinking of not only the technical but also the philosophical foundations of science. Furthermore, one of the key challenges is creating more transparent and explainable models that will increase user trust and minimize potential negative consequences. This requires developing tools for interpreting decisions and detecting errors, which is particularly important in critical areas such as medicine and finance. The expanding use of AI across various fields raises the issue of regulation and legislative oversight to prevent abuse and ensure respect for human rights. Furthermore, it is necessary to address the issue of resilience to adversarial attacks, specialized attacks that can mislead systems. Development prospects also lie in the implementation of training methods with less labeling and increased energy efficiency of models, making technologies more accessible and environmentally friendly. Developing ethically responsible algorithms requires collaboration between engineers, lawyers, philosophers, and society at large, creating a holistic approach to the future of AI. It is also important to consider the social consequences, displacements in the labor market, the need for retraining specialists, and strengthening educational programs. The uncertainty surrounding the future of artificial intelligence is determined by the rapid development of technologies and the simultaneous unpredictability of their long-term impact on society. Possible scenarios range from benefits and improved quality of life to the risks of losing control over systems. Consequently, there is growing interest in creating international ethical norms and mechanisms for global cooperation capable of ensuring the safe and fair implementation of AI. Thank you for your attention. During the presentation, we examined in detail the development and design of algorithmic systems using neural networks as an example. We analyzed both the technical and historical aspects of their creation, examined the achievements and challenges of modern artificial intelligence, and reflected on the prospects and limitations of the future. I would be happy to discuss any questions related to this topic.